All right, here we go. We are going to do some virtual. Boards go up, please, with undetermined coefficients, which this is intended right now to get you ready to do undetermined coefficients in with systems. So this, for each of you, is likely a throwback to something that we did a long, long time ago. So what we're going to do is find the general solution to each of these. Remember, that is an XC plus an XP for each of these. The first one is x double prime plus 6x prime plus 8x equals 5t squared minus 1. Now, if you feel like you remember how to do this, go ahead, just go do it. If you feel like you want me to do a refresher with this first one, then I'm just going to scroll down in a moment so you can see it. And then hopefully you can go and try to attack 2, 3, and 4 on your own. So if you want to try it on your own, go. If not, here comes the solution. Let me zoom out just a hair. Okay, so this is the general solution to this thing. X equals C1 e to the negative 2t plus C2 e to the negative 4t plus 5/8 t squared minus 5/16 t plus 27 over 64. These two exponential terms could be switched and your answer would still be correct. So let's talk about how we do this. The first thing we do is we find our XC. We do that by we use the characteristic equation for this without the 0 on that right hand side. That gives me r squared plus 6r plus 8 equals 0. Factor negative 4 and 2 are my r values, so that gives me x equals c1 e to the negative 2t plus c2 e to the negative 4t. So that's a little throwback to first semester. And the next thing, and the reason we're doing this is because we're going to do this with systems of differential equations soon. So we need to go back to this and be like, all right, now I remember how to do this. I can do it with systems, and then we're going to go ahead and take it a little bit further. But XP is, we determine XP by looking at this right here. That thing is a 5t squared minus 1. So the rule is to take all of the pieces of these and derive them until they either repeat or they go away. So if you take a look at this, this is a polynomial. All of its derivatives until they go away could be represented with at squared plus bt plus a constant. The a, the b, and the c are my undetermined coefficients that we need to figure out. This is sometimes called judicious guessing. So what do? We want to find the xp that's going to pump that stuff out. So notice this is x double prime plus 6x prime plus 8x. So I am guessing that that is x. So that piece right there is going to go in right here. Notice I need to have x prime and x double prime. So I'm going to need to take the derivative of this line right here. That's this. And then the next derivative, which is this right here. From there, I'm going to go ahead and plug each of these different pieces in, and maybe I will highlight some stuff here. So you can see I take all these undetermined coefficients pieces, and this is x double prime. It goes in there. That's why I have this 2a right here. You can see that's now highlighted there. Then I get a 6. Then I get an x double prime. Well, that's my orange piece here, so that goes in here, 2at plus b, wha-bam. And then same thing, this thing goes in here, it shows up there. From there, I just distribute things, and then this highlighting is color coding all the unknown pieces on the left-hand side to the different pieces that I have on the right-hand side. Notice it's 5t squared minus 1, so I got the 5t squared. I have no t's there, so I put a 0t term in there. And then I put a minus 1. From there, I go ahead and build out a system of equations. So I'm taking this, which has 3 unknowns, and turning it into a system of 3 equations. You can see here, the 8at squared is the only t squared term on the left side, and the only t squared term on the right side is 5t. So the equation that I'm going to get for the t squared terms is 8a equals 5. And you can see, if you know how these matrices work, which you should, that's what this line right here is representative of. The 8a is equal to the 5. This is my t squared line. Then I go and I build out the same lines for the other two terms. This 12 goes in the a column, and it's the t's here, right? The 8, this t, 8b, so 8 goes in the b column, and then there's no c's, so I put a 0, and then I put a 0 on the right-hand side because of that thing. Then we've got the 1 term, right? The no t terms. I've got a -1, so that goes on the right side, and then a 2a, a 6b, and an 8c, so 2, 6, 8. From there, I plug it into my calculator. You don't always have to plug it into your calculator. Sometimes you can do this without a calculator. I typically, I'm focused on the differential equation side of things, not the algebra, so I'm going to plug it into my calculator to make sure I don't mess that up. I've got this right here. I RREF it. That's reduced row echelon form. I get A is this, B is that, C is that. And from there, I come back to this purple one right here. Remember, this was my guess at XP. So I take that A value of 5/8. This becomes -15/16, and this becomes 27/4. And remember, the solution to this equation here is XC, which is this stuff, plus the XP, which is this stuff right here. And we're going to do the same kind of things with systems of differential equations and inputs like this piece right here. So hopefully that makes sense. Hopefully you're ready to try the next one. So let's scroll up and look at it. All right, next one, I'll read it out loud for you, is x double prime plus 6x prime plus 8x, oh, that's the same thing. Oh, they're all the same thing. Look at that. Equals 5 sine of 2t. So your xc stuff is going to be really easy. It's really just finding the xp for all of these. So hit pause. Go ahead and try this one. Remember, derive until it goes away or repeats. Okay, here comes your answer. So in this one, I have the same xc. I'm going to let my xp be a sine of 2t plus b cosine of 2t. That's because the sine derives to cosine and then comes back to the sine. So it repeats itself, right, with that 2t on the inside. We only care about this part of the function. We don't care about the 5 because we're going to take care of the 5 when we set up our system of equations. So xp, take the derivative, take the next derivative, be really careful with your negatives, with sines and cosines, and your chain rule. From there, I plug it into this. So this guy, this term right here, is right there. Then I have a 6 times x prime. So if I do 6 times these two terms, that gives me 12s instead of 2s. And then 8 times these gives me these. And then I set it equal to the 5 sine of 2t. That's where the 5 comes into play. We don't need to worry about it until now. From there, notice I've only got an a and a b, so really I'm looking to make 2 equations. So when I make my 2 equations here, I got sine terms, right, that are underlined there, and then that's equal to the 5 sine of 2t. So notice I got 4a, and this is a b, and that's an a, right? So I actually have negative 4a plus 8a. That's where this 4 comes from. And then the negative 12 is the only b term, so it goes there, and then the 5 goes here. Same thing with the cosines. I get this stuff. And then why is there a 0? For the same reason that we had a 0 for this t term right here, there isn't a cosine term on the right-hand side of this differential equation. RREF it, I get c1 e to the negative 2t plus c2 e to the 4t plus 1/8 sine of 2t minus 3/8 cosine of 2t. All right, let's go to the next one. X double prime, blah, 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 same thing, equals 7 e to the 3t. So remember, we derive the right-hand side until it repeats or goes away. So go ahead, hit pause, see if you can do it. Here comes the solution. you should get C1 e to the negative 2t plus C2 e to the negative 4t, same thing, plus 1/5. Hopefully you got 1/5 e to the 3t. This one goes a little bit quicker than the other ones because e to the 3t derives directly to e to the 3t. Remember, we don't worry about the 7. So I do a e to the 3t, 3a e to the 3t, 9a e to the 3t. Just some chain rule there. Then I plug them in appropriately to this equation right here. And this is where I get all these e to the 3t's. And in fact, I can just divide this line by e to the 3t to get this equals 7, 35a equals 7, and do some division and get a is 1/5. So we don't even need a system of equations for that one. Kind of nice and convenient. All right, let's go up to the last one. Same thing, x double prime plus 6x prime plus 8x equals 2e to the t. Before you hit pause, let me warn you, just be really careful with your product rule throughout this entire process. Remember, you want to derive and get all terms until they repeat or go away. So now you can hit pause. You should have, maybe you didn't hit pause. You should have an A and a B for this one. That's all. See if you can find what the A and the B functions are. Okay, here come the answers, the solution. All right, if I just look at the t e to the 2t, it derives to this. And then, look, this is a repeat of that term. And then the other piece that it derives to is e to the t, which will just continually repeat to itself. So the two pieces that I need to worry about in my xp are those guys. So I get an a times the first one plus a b times the second one. Oh, I should show you the answer. Bam, there's the answer. 2/15 and negative 16 over 225. If you got that, great. If you want me to walk through it, here we go. And I'll zoom out so you can see the whole thing all at once. All right, this, some product rule, right? And then I do one more derivative. You might need to do a line in between this line and this line before getting that 2a, so that you don't lose track of things. Then comes kind of messy in terms of all these multiplications here, because all the terms are really similar. So just be really careful with that. I'm not going to read this whole line out loud, but I do all that multiplication. You can see the 6's and then the 8's on these guys, and it gives me the 2e to the 2t because that's what we have over here. Whoops. And then from there, things simplify down very quickly. What do I get? I combine all my AT terms, or the TE to the T. Oh, look, all of them have A's on them. This one does, this one does, this one does. If I add them up, I get 15 equals 2 TE to the T. So I can quickly solve for A equal 2 over 15. From there, the orange and the blues are the oranges are the e to the t's with a's, the blues are the e to the t's with b's. If I combine those like terms, I get an 8 and a 15. And then you could use a calculator if you wanted for this, for the RREF, but once I have the a equal to 2 over 15, I can plug that in here. And notice I divided by e to the t from this line to that line, and do some algebra and get this negative 16 over 225. And my answer is the XC plus that XP. So hopefully you're good and you remember this stuff from a long, long time ago. It's going to help us as we pop into doing this undetermined coefficients method with systems of differential equations.